The fundamental job of an ignition system is to provide spark at the spark plug at the right time. The question is, how does that spark get generated? By using the ignition coil. We're going to take a look at how an ignition coil works. This is a diagram of a cutaway of an ignition coil. This is an old school ignition coil, but they all work fundamentally the same on the inside. First, you'll see that there's two loops of wire. One of the loops of wire is called the primary winding. The primary winding is shown in blue in this diagram, and it's just a loop of wire that loops around and has two ends to it. One end is hooked to 12 volts positive, and that 12 volts positive comes in through the ignition switch. That's where the ignition switch gets its term ignition switch, because in the olden days, the ignition switch used to provide direct power through a switch to 12 volts. When you shut the car off, you would actually kill power to the coil. Until fuel injection came around, there was no way to shut fuel off in a carburetor, so you would kill spark. Again, the primary winding has two ends. It's just one piece of wire with two ends. One end is hooked to 12 volts. The other end, as you might expect, is hooked to ground. When you take any coil of wire and you hook one end to 12 volts and the other end to ground, you create a circuit. And in that circuit, current starts to flow. Let's take a look for a second at why we call it a coil. This is an actual coil from an ignition coil. This is what's actually on the inside. Now there's more on the inside than just this, but this is an example of a coil. The reason they call it a coil is because it's a piece of wire with two ends on it, and it's wrapped in a loop or a coil. So this is one wire that stretches this whole length, and it circles around, and then it comes out over here. That's one piece of wire. The wire has insulation on it, that's why it's so red in color, so that the individual turns or loops of wire don't touch each other. So that's what an actual coil inside looks like. And again, there's more on the inside than just that. Here is everything found inside of an old ignition coil except for the penny. The penny is just there for size reference. We'll get back to that in a second. When I look at an ignition coil like this, again, there are two loops of wire. So we've looked at the primary, and then down inside, there's also another loop of wire that comes around and turns around there called the secondary winding. So there's a primary winding and a secondary winding. There are two coils or two loops of wire inside of an ignition coil. So what are they there to do? The primary winding's job is to create a magnet. When you want the primary coil or primary winding, again, we call it a winding because it's wound around in a circle. We can say that those windings are turns, just meaning it loops around. These are all just different words made to confuse you. So if we apply 12 volts on the positive side and we ground the negative side, one of the things we know is that when you do that, you're going to send current through the wire, and because it's wrapped in a circle, it's going to start to create a magnetic field. But because it's in a coil of wire, that magnetic field will flow out like this, just like the planet Earth. If you were to look at Earth sitting in the middle, and you'd have like a North Pole and then a South Pole, and the magnetic lines of flux or the magnetic field comes out one end and goes in the other end. Even though they're invisible, that's how it works because Earth is a giant magnet. How do we know this? Because of a compass. Compasses wouldn't work otherwise. So back to an ignition coil on a car for a second. So if we put 12 volts here and we ground this, then the primary winding becomes a huge magnet. And now we have a magnetic field. That's awesome. We can create a big magnet. We also know that if we take this ground away, the magnetic field stops or the electromagnet turns off. And what we know about that is that when you do that, the magnetic field doesn't just immediately disappear. What it does is it shrinks, and we call that collapsing, when the magnetic field collapses. So the magnetic field builds when you ground the negative side of the primary winding, and it shrinks when you take that ground away. Let me say it a better way. When you ground the negative side of the primary winding, you create a magnetic field, it builds. When you take the ground away, it collapses. And as that magnetic field collapses, it's doing something really cool. As it collapses, it's moving across the secondary winding. So there's a second set of wires in there, again, the secondary winding, that is being affected by the movement of the magnetic field. Remember that the way to create electricity in a wire with a magnet is to either move the magnet over the wire or move the wire over the magnet. There has to be movement. That's why windmills don't produce electricity unless there's wind and they're spinning. Alternators don't produce electricity unless there's a belt and they're spinning. There has to be movement. In the case of a coil, the movement is the natural movement of the magnetic field collapsing. Now, when we talk about the movement and the time it takes to collapse the magnetic field, that happens very, very quickly. We're talking microseconds, but it is happening over a period of time. And while that's happening, it's slicing across or moving across the secondary winding. And as it moves across the secondary winding, it is going to generate a high voltage. So where is the secondary winding connected to? Where does that secondary winding go? Where does this wire go? Well, eventually it goes to the spark plug. Now, how does it get to the spark plug? Well, if there's only one ignition coil and that lives on top of the spark plug, it goes directly to the spark plug. However, if this wire that comes out of here is one coil for the whole car, this here then will be fed into another device called a distributor cap and rotor. And then the distributor cap and rotor will distribute the spark out to the correct cylinder at the correct time. So again, inside of an ignition coil, you have a secondary winding or loop of wire, and you have a primary winding. And the primary winding's job is to create a magnet. And the secondary winding's job is to create voltage, a high voltage. And because the primary winding and the secondary winding have a different number of loops or turns, you can actually step the voltage up or step the voltage down depending on how you do this. In an ignition coil, they step the voltage up. So to explain that, if we apply 12 volts to the primary side, and let's say that the primary winding, instead of having 200 turns, let's say it only had one turn. And the secondary side over here has, I'm just going to make a number up, let's say that this side has 10 turns. So the primary side has one turn, and the secondary side has 10 turns. So that will, when this magnetic field collapses, in theory, that is going to take are 12 volts and multiply it by 10 because there's 10 more loops over here. So now I would have 120 volts on the secondary side. So I would have 120 volts up here created by the 12 volts on the primary side right here, and then this would be grounded. Remember, when does this happen? It happens when the magnetic field collapses. As the magnetic field collapses, it moves or collapses and slices across both of these wires, but as it slices across the secondary wire, it induces a voltage in that wire that will be much higher in this case than the primary winding. This shows the actual ratio of 200 to 20,000. That's probably closer to where we're at, where there may be 200 twists around the center on the primary winding, and there may be tens of thousands of twists of the secondary winding. That's how we get the high stepped up volts. To look at a real world example of this, again, this is a primary winding. This is what's inside of an ignition coil that I took apart, and this is an old school coil, but the theory is the same. So right here, this one here is the primary winding, and this one here is the secondary winding. So it's kind of hard to see because we're not zoomed in very much. However, if you look at the secondary winding, you think, well, down in here is where the wire is. Remember, it's just one very, very long wire, but it's wrapped in paper and insulator. Again, the penny is just here for size reference. So when we look at the primary winding, you can actually see the loops of wire, but remember, that's just one long wire going all the way from start to finish. So here again is a more zoomed up look at that primary winding, and that may be 200 turns, I don't know, around there. So you can imagine that wire looping around 200 times. What's important is to think about, well, how many times did the secondary winding loop around? And we already said that it's going to be tens of thousands of times. So this wire here, the wire that's inside, is going to loop around tens of thousands of times. And this little strap that you see right there is not the size of the wire that is inside. The size of the wire inside is very small. Here's an example. So this is kind of a weird thing to see, but you can see that there's a penny there for size reference. So this right here is the primary wire. And, you know, it's a small wire, but I mean, it's what, 16, 18 gauge? And there is a piece of the secondary winding right there. That is a piece of the secondary wire. It is the secondary is much, much thinner than a piece of hair. We're zoomed in quite a bit here to get this shot. And remember, again, I can't state this enough, that this secondary winding with this right here, with tens of thousands of loops around in there, that is one wire end to end. If anywhere along that wire you get a break, like right here, I made this break so that we could see, so that we could look and see how small the wire is, that right there, now you've got a no spark condition. So again, to review, every ignition coil is going to have a primary winding and a secondary winding inside. The primary winding's job is to create a magnetic field. The secondary winding's job is to create a high voltage from the collapsing magnetic field of the primary side. Also, don't forget, the primary side has two wires. One of them is always going to be 12 volts. The other wire is going to be taken to ground when it wants to turn on the magnet and build a magnetic field. And then when the ground is removed, That's when the magnetic field collapses and the high voltage is created in the secondary. So spark happens when the ground is removed from the primary.